Welcome. This is Professor Hiren Trada. In this short video, I am going to cover how you can solve for the questions in Prelab 3 of the lab course EE361, which is the electronics lab course accompaniment to EE321. Okay, let's get right away into the questions. So let me bring up the Prelab questions here. Let us see. Share. Okay, so these are the questions. There's only one page, question 1, 2, and 3. And let me tell you that you can find answers to all 3 questions in the lab write-up. So if you have not yet looked at it, I would suggest you do so. But I can go ahead and show it to you. Right here in the lab manual, there's a background section. In this background section, you can find the theory of the operation of the BJT. This lab is about using a BJT or a bipolar junction transistor as an amplifier. More specifically, the configuration is a common emitter or CE amplifier. Okay, so to use the BJT as an amplifier, we will operate the BJT in the active region, meaning we need to set the Q point or the operating point somewhere in the middle of this active region. To do that, well, we have a few equations that we need to look at. So question number 1 is basically asking you to determine the Q values IB, IC, and V out for this circuit. The information is given to you, VFB, B spec, VBB. So is the input, the AC input, 100 sine omega t millivolts. If you go into your Prelab, you can see there are equations for IB, IC, and V out. Okay, these are the equations you need to use to solve for question number 1. Okay, rather straightforward. Okay, question number 2. Determine the AC gain for the circuit. Okay, AC gain is basically, well, let me go over here, V out over V in. So let's do this. We are done with question number 1. 2 is AC gain. AC gain is simply V out over V in. And the answer to this is also in the lab write-up. So what you need to do is you need to calculate V out, okay? Because V in is already given to us. V in is given to us as 100 millivolts sine omega t. Okay, 100 millivolts. If you remember from EE201 and you compare this to the standard expression for a time varying sinusoidal waveform, you remember V in as a time varying waveform is given by the peak value or the magnitude Vp sine omega t plus or minus theta. Vp is the peak value or magnitude or amplitude of the waveform. It is also referred to as Vm, right? So here, this is 100 millivolts or 0.1, if you will. Okay, so Vn is given to you. All you need to do is calculate V out. Well, to do that, let's go and take a look at the lab write-up. So the lab write-up, let's see if we can find an equation for V out. Well, there it is. VCC minus ICRC, because look where V out is connected. V out is connected to the collector terminal, right? And so it's measured between the collector and ground on the circuit. If you apply KVL as the red arrow shows, you get V out is 15, which is VCC minus ICRC, the voltage drop across the collector resistor. Okay, and that's basically what's given here in these equations, equations 3.4 to 3.7. These are the ones you need to solve for problem number 2. Okay, problem number 2. And that's it. As easy as that, or rather, let me not use the word easy, as straightforward as that. And the answer to question number 3 is also there in the lab write-up. Okay, so if you read the background section, again, it is there in the lab write-up. So there you have it, a short video about solving Prelab number 3 for EE 361.